to invest. She wants to make $6,000 per year.
She wants to make $6,000 per year.
Or, sorry, she needs to make $6,000 per year.
So in interest, in addition to that,
In
okay?
interest.
So interest, because I need to know what those numbers represent. So this is what she has. So this is the investment.
But there's more to the problem.
Yes, I know. I'm just verifying so far. So she has $60,000 to invest, and she wants to get a $6,000 interest per year. Good.
One bond investment pays 15% yearly interest, and then the other bond pays 7% yearly.
Okay.
Now it says set up and solve an equation for how much the woman should invest in each option to sustain exactly $6,000 per year.
Excellent question. Okay. So the person has $60,000 and takes an amount, unknown amount, from the $60,000 and takes it to the first bank or puts it in a bank in a bond that pays 15% per year. Without counting, she takes the rest of the $60,000 and takes it to a bank, puts it in a CD that pays 7%. So for now, this is what we know. The amount is $60,000. It's split into two different unknown amounts, one that pays 15% and the other one that pays 5%. And at the end of the first year, she wants to get an interest of $6,000. She doesn't know how to split the amount. How much to deposit in the bond, and what would be the rest of the bank with 5%. So that's our question. So our first equation, first of all, I see two variables here, x and y. Our first equation must be common sense. Can anyone come up with an equation that we see here? Just looking at this, what would you say? Okay, one more time. We have 60,000. We take part of it without counting it to a first bank, and we deposit it there. And then we take the rest to the second bank, we deposit it there. What is the first equation? Yes, please. Flynn?
Would be 6,000 equals.
We haven't talked about interest yet. I haven't mentioned anything about interest. Yes, Mike?
60,000 equals 1.15.
We haven't talked about interest yet. Equals? Thank you very much. This is the first equation that we just talked about. Nothing else. We haven't mentioned anything about interest yet. So at the end of the first year, she goes to the first bank and she gets an amount. That is just the interest. She does not remove the 60,000 or the X from the account. She leaves it over there, but she says, just give me my interest. She goes to the second bank, does the same, gets her interest, and now we talk about interest. Some interest is coming from the first bank, and some interest is coming from the second bank. Can anyone tell us what is the interest per year, just 1 year, on the money that is X that we deposit in the first bank? Say again? We cannot use percent in an equation. Flynn? 0.15 of? Excellent. So 0.15 of X is the interest on X that we collect, or she collects from the very first bank on December 31st. Very good. What about the second bank? What comes out from the second bank? 0.05. Why? Oh, I'm sorry, my apologies. Very good. Thank you. Okay, so now we have a system, two linear equations in how many variables? 2. We have several options here. One option would be to solve this equation for either x and y and plug it in. Another option would be to use elimination. Whatever you want, I'll do it. There are many other options. Kramer's rule, matrices, inverse matrices, all sorts. So pick one. Okay, so we want to substitute. Which variable would we like to substitute for? It doesn't matter because both of them have a coefficient of 1. I would always choose the one that has coefficient 1. If it doesn't have coefficient 1, don't choose it because you're going to use a fraction. Can you solve it? Yes, of course. But I don't recommend that method if none of them is 1. Okay, so which one do we want to solve for? Okay, we want to solve for y, so this is negative x plus 60,000. We're going to replace y in the second equation by this. So 0.15x plus 0.07 times negative x plus 60,000 equals 6,000. Now this became a linear equation with one variable, so let's just go ahead, distribute, combine like terms, move terms, whatever. So 0.15x minus 0.07x plus 4200 equals 6,000. So this is 0.08x equals, is it 1800? Please correct my numbers if they're not correct. Anytime. Am I okay? So then x is 1800 divided by 0.08. So what do we get? I got 22,500. So the first investment that goes to 15%, 15% per year, 22,500. Now, obviously y is very easy to determine because it's 60,000 minus 22,500. So y would be, so 60 minus 25 is 35, so 34. Correct my numbers anytime, please. Am I okay with the numbers? Okay. Now, this is good, but it's not good enough. I don't need anyone to tell me whether this is the correct answer or not. I'm going to do this. I'm going to check 0.15 multiplied by, that was 22,500. So please do not just put a number in there. You can always check 0.07 times the difference, which is 34,500. Don't just put a number in there to see. So I do have an error. There is something wrong, right? Or either I typed something incorrectly here, but I'm not getting 6,000. So now I know that I made an error somewhere, and I have to go back and correct it. So don't just put in a number and see if the system says okay, right? Just check. So let's see what I did.
37.
This one is 37?
It's 37. 37,500. Not.
What did I do?
You said 34.
Oh, so here's 37?
Yeah.
Okay, sorry about that. So see how I catch my mistakes? By simply going back and check. So second and entry, thank you so much, Connor. So this was apparently 37. And if the answer is not 6,000, then I'll say, I will not put it in, just for the system to tell me, oh, it's wrong. I'll check before I put it in. Excellent problem, Mike. Thank you so much. Anything else? Is there anything else? Is this okay? Mike? Yes? Okay. Let me show you again where we are. We are here. We're going to look at a couple of problems from... You're too patient today with me. Sorry. So we're going to look at a couple of problems from inverse functions in 5.7 because we finished that. We're going to look at 4.2 modeling with linear functions. And I am going to look at this, choose a couple of problems from this supplement. I don't think I printed it out for you, did I? Modeling with functions. I don't think so. So I send it to the copy center. It will come in and I will give it to you on Tuesday. It's posted, but I want you to have a hard copy as well. So we're going to work a little bit on this, a couple of problems, and then we're going to start chapter 5. So that's the plan for today. With quadratic functions, I'm sure this is going to be terribly boring for you because we have seen quadratic functions over and over. And then polynomial functions. And you have this supplemented from last time. So we're going to hopefully be able to get to that. Ready? Okay, so let's look at more inverse functions. Any questions about inverse functions from last time? Any questions? Would you like us to determine the inverse function? We looked at the inverse function of a rational function last time, and we have not looked at an inverse function of a radical function. What do you think? Yes? Okay, perfect. Let's do that. So then we continue, let's say, with 17, and this is on page 444. Very good. So this is f of x equals the square root of 3 minus 4x. We're asked to find the inverse function of this function. By the way, is this one-to-one? We can picture any radical function now. It's this. It's this, or maybe this. It depends on the coefficient in front of x. So it is one-to-one by the horizontal line test. Okay, first step, please. Very good. Step 2. Very good, awesome. And remember, we are solving for this now. Step 3. Great job. Good. How? Very good. It's a radical equation. Awesome. So this is x squared equals 3 minus 4y. Before we continue, and I should have said that from the very beginning, don't look at anything just yet. I need to find the domain of this function. What do I have to write to find the domain? This is our best friend. We can never forget our best friend. 3 minus, excellent, Flynn. Thank you. So this is negative 4x greater or equal to negative 3, or x less than or equal to 3/4. So now let's identify the domain of f, which you already have, negative infinity 3/4. And let's identify the range of f, which we know for sure always, if there is nothing attached, there is no minus in front, there is nothing attached behind it, what will be the range of any square root? Picture the graph and say, of course. I don't have the inverse function. Can anyone give us the domain of the inverse function? Awesome. And the range? Very good. Awesome. We can continue. So then what I would like to do, I would like to do this. It doesn't matter. You can multiply by negative 1. So 4y equals negative x squared plus 3. And y equals negative 1/4 x squared plus 3/4.
Instead of 1. Yeah.
Sorry about that. So we solved in step 3. We solved for y. In step 4, all we have to do is f inverse equals negative 1/4 x squared plus 3/4. Now picture this graph. What type of function is it?
Okay.
Either opening up or opening down. But is this a one-to-one function? Okay, so that's why, comma, for x greater than or equal to 0. Remember what we did last time? We had to truncate a domain. So that's the reason why I highly recommend every time you find the inverse function of a function, especially like this one, if it's linear, you have nothing, no restrictions to write. But if it's a square root, always start with the domain, figure out the range, because this answer is incorrect. This answer is incorrect. Now this is correct. This answer is correct. You understand that function must be 1 to 1. If I start with a 1 to 1 function, the inverse function has to be 1 to 1. The inverse function is 1 to 1 because the function is 1 to 1. Otherwise, there is no point in discussing the inverse function. So this is the correct answer. How did I determine it? Yes, really? Go ahead.
For when you found the domain and range for the inverse function, so did you, for basically.
I did not even look at the inverse function. I grabbed or took all the information from the function itself.
Yeah, and then you made the range the domain for the inverse.
Correct, because that's by definition.
Okay.
If a function is defined on A taking values in B, the inverse is defined on B taking values in A.
Okay.
Mandatory, always,
And
forever.
then, I'm not gonna remember, but how did you know it wasn't 1 to 1?
Because it's quadratic.
Or there's another 1 to 1?
No, cut them with a horizontal line.
Okay.
That's why this is quadratic, this is 1 to 1. This one is not.
This is horizontal line.
Correct. Yes. Very good. Other questions here? Let's look at another word problem that involves inverse functions, although we may not even be aware of that. So here's one here, an object. Let's read these two. You choose, or you can choose 59, or it doesn't matter. Any problem. An object dropped from a height of 600 feet has a height, h of t, in feet after t seconds of this form. Express t as a function of the height h. We're going backwards. We're just finding the inverse function. And find the time to reach a height of 400 feet. That's one option. The period t in seconds of a simple pendulum is a function of its length, and this is the function. Express L as a function of t. Any preference? Okay, 57 it is. So let's take a look. 57 on page 445, and that is h of t is 600 minus 16t squared. And we are told that this is in feet, and time is in seconds. Express t as a function of the height h. And find the time to reach a height of 400 feet. Okay, so basically I'm asked to find the inverse function. What is the first step? Yes, yes. So then y equals 600 minus 16t squared. Well, in this particular case, they're asking us to keep t. So I don't need to change the two. I just have to solve for t. But it's right. It's okay. You can write this t and this y. You can. But then when I write a final answer, it has to be in terms of t. So in this case, there is no need for this. You're correct in what you said. Well, this is the correct step in finding the inverse function. True. But this time there is no need because they want us to keep the variable t. They want us to solve for t, which is the same thing. So this will be y minus 600 equals negative 16t squared, or 16t squared equals negative y plus 600. And all we have to do is divide both sides by
16.
Exactly. Perfect. So then t equals negative 1 over 16y plus,
Wait, what is t squared?
it was t squared, yes. T squared plus 600 divided by 16. And then we have to take the square root from both sides. Remember one thing from here, before we continue. What is the domain of this function? Correct, but it will not be a one-to-one function, and time cannot be negative. So the domain of h is nothing else but 0 to infinity, and now we have to find its range. Range of h. So let's picture this graph. So this is t squared multiplied by 16, flipped, and up 600, and only on the positive side. So t squared stretched by 16, flipped over the x-axis, up 600, but visualize only this side, not this side. So what is its range?
600.
Negative infinity to 600. Awesome. We didn't even graph the function, but we know transformations. So negative infinity to 600. You know why this is so important, right? Because now I will have to take the square root, right? From the quantity that I am determined for the inverse function. So then I know now that the inverse function is defined on negative infinity to 600 and takes values on 0 to infinity. Okay, I have to make sure. So now we're ready to take the square root. Any questions so far? Any questions? Any questions? I can simplify this a little bit. By what? By 4, right? By 4, I get 150, right? And this is 4. Okay, I can continue and simplify again by, so this is 75 over 2. Okay, so then t squared, bless you, you will write plus or minus the square root of negative 1 over 16y plus 75 divided by 2 after we took the square root, of course. And now the question is which one? It's not such a big deal in this particular situation because time cannot be negative. So I know exactly that it must be positive. But also I know from here, the answer of this cannot be negative. The range is 0 to infinity, so this answer can only be positive. So I will say definitely only this and nothing else. So this is the inverse function. So we solved the given equation for t. Now they're asking us to find the time, find t for the height of 400. What do I have to do? Yes, indeed. So if you want to put this as a function, you can write this. This becomes t of y if you want. So this is the square root of negative 1 over 16 times 400 it was. Yes. Plus 75 divided by 2. So what do we get? So when I simplify this by 8, I get 50 over 2. So 75 minus 50 is 25. 25 divided by 2. So the square root of 25 divided by 2 seconds. And yes, I have 5 divided by the square root of 2, so I will determine that. So 5 divided by the square root of 2, roughly, it's 3.54. So in about 3.54 seconds, the height will be 400 feet. Any questions for me? Okay. Yes? Any question?
Yeah.
Yes, please. Really? Go ahead.
How come when we were trying to find the time at
Yes.
400 feet, why don't we plug it back to the original equation?
Because we have the distance. The distance is given. Y is given to find t.
Yeah.
But since I have a formula for t,
Mhm.
and I am given the distance, I'm going to use it.
Okay, I don't know if we just easier to do 400 equals 600 minus
You can.
16.
You'll get the same answer.
Okay.
But that's why we were asked to solve for t. So where is the original? So here it is. So then you have 400 equals 600 minus 16t squared. You can, if you want to check. So this is negative 200, negative 16t squared. So t squared is 200 over 16. And we take the square root, but I want to simplify. So if I simplify by 4, I get 50 over 4. Again, the same thing. T squared equals 25 over 2, and I get the same thing. That number, 3.54 seconds. Yes, you can always go back and do that, but that's what was the purpose of all this. The purpose was to find the inverse function, to solve the equation for t, and plug in y when it's given. But yes, you can. You don't really have to use this. Nobody's forcing us to use this. You can go back and use the original equation. Oh, of course. Very good question. Okay, so I think we're done with that. So let's look at modeling with linear functions. And then we're going to choose a few problems, 1 or 2 problems from the supplement. And then next time when I bring you the supplement, we can choose other problems from there. Okay. I don't think there is anything new in here with linear functions and finding a different... So for example, I think that these are interesting problems. We had one, because we used to teach this at the beginning of the course, not somewhere in the middle. So if you remember, we had a similar problem, if you read it. We had a similar problem on the previous test that I gave last semester, not last semester, it was last year. So let's choose a problem from here about linear functions. We can do the phone company, we can do something else. The moose population, another phone company, town's population, school's population, federal helium reserve. I guess it's going very distinct almost. Which one, the phone company, this one or this? It doesn't matter. Okay. So let's look at 47 then. So a phone company has a monthly cellular plan where a customer pays a flat monthly fee and a certain amount of money per minute used on the phone. If customer uses 410 minutes, take notes, 410 minutes, the monthly cost will be $71.50. $71.50. Okay. If the customer uses 720 minutes, the cost will be $118. Find a linear function that monthly for the monthly cost of the cell plan of a function as a function of x, the number of monthly minutes used. So they want us to call this x, and they want us to call this y, of course. Always be careful when you identify the independent variable and the dependent variable. So the amount of money is dependent on the time used. Cell phone was used. So what is given in this problem? 2 ordered pairs. In the problem, we have 2 ordered pairs. Careful, the independent and dependent. Can anyone give us the 2 ordered pairs? Yes, 410, 71.5, and 720. Okay. This is very important. We are told the relationship is linear. Find a linear equation. So let's find a linear equation. How do we do that? What is the first step? We have to find, very good, awesome. Let's find the slope. y2 minus y1 over x2 minus x1. 118 minus 7150 divided by 720 minus 410. So let's see what number we get. And 720 and 410. I got 0.15. Okay? Now, 0.15 means nothing without a measurement unit. This is a word problem. We cannot just say 0.15. So what is 0.15? Remember a measurement unit? Yes, Mike? Careful. Dollars per minute. Because, so the measurement unit has it's a ratio. The measurement unit for the top over the measurement unit for the bottom. The measurement unit for the top is dollars, because that's what we have. And the measurement unit for the bottom is in minutes. So this is 15 cents per minute. We agree? Okay, perfect. We found the slope. Now what?
What was the rest?
So we want to find the equation. Very good. Since none of these 2 points is the y-intercept, I will use y minus y1 equals the slope times x minus x1, which is the point slope form. We agree?
Yes.
So this is point 15. It doesn't matter which point we use. If you use the first point and I use the second point, we still get the same equation. Which point we would like to use? You want to use the one with decimals or the one without? It doesn't matter really, because we have point 15 anyway. So 720 and 118. So therefore, y minus 118 point 15 times x minus 720. We distribute 0.15x minus 0.15 times 720, but plus 118. So what did you get? I got 10. Correct me, please. At any point in time, please calculate or make sure that I do any miscalculation. Okay, next question. Am I okay? Am I okay? Anyone checked? Did anyone check? No one checked? Part B. Interpret the slope and the y-intercept of the equation. You got 11? Let me check my numbers. Negative 0.15 times 720 and plus 118. I got 10.
Okay, I see what you're doing.
That's okay. I'd rather check and go back. It's fine. So here we're asked to interpret. We already did interpret this. So we don't have to interpret this anymore. It's 15 cents per minute. But they're also asking us to interpret the y-intercept. So this is the y-intercept, 0, 10. What does it mean? If we don't even touch the phone per month, no minutes, we don't touch it, we don't call. That's it. That's it. So this is the monthly fee. So 10 monthly fee, even if we don't call anyone. Very good. Use your equation to find the total monthly cost if 687 minutes are used. What am I doing now? 687. So please give me this number. 0.15 times 687 plus 10, and this is the cost, and it's in dollars. Do you think we need more examples from linear equations? Are we okay with this? We need another one? Yes? Is there a yes? Okay. So let's do another one. Okay, so let's look at problem 50. Any questions on this? Can anyone give me the number? 113 point? Very good. Can anyone confirm?
Yeah.
Okay, excellent. So let's look at problem 50. Same page, page 320. Is that okay, everyone? Okay, so in 2003, I take notes when I read. The owl population in a park was measured by 340. By 2007, they dropped to 285. The population changes linearly. Extremely important piece of information, because if it changes exponentially or in a quadratic form, then we cannot use a linear function. So this is a very important piece of information. Okay. Let the input be years since 1990. So 1990 represents x equals what? If the input or the study started in 1990, what is the time for that represents 1990 then? For someone born in 1990, how many years of age? 0, right? 0. Okay, what does 2003 represent in that case? To x equals 13. What does 2007 represent? That's it. So we keep that in mind. Good. Find a formula for the owl population. They want us to use P. It doesn't matter. I'm fine, whatever you want to use. Let the input be years since 2003, however. So they should have, now they're changing the strategy on us. Now they say the input be years since 2003. Okay, so I don't know why they put that in there. So then 2003 is x equals 0, or we can go along with this, which is still fine. But what's the point? So x equals 4. So 2003 is the number of years, x equals 0 since 2003. 2007 is the number of years 4 since 2007. Which means in this problem we are given again what? 2 pairs. Very good. So 0, 340 and 4, 285. Like before, we find the slope. So let's find the slope. 285 minus 340 divided by 4 minus 0. Do you expect the slope to be a negative number or a positive number? In 2003, 340. In 2007, 285. You expect a negative slope. Excellent. Very good. So what do we get? Negative. How much? 55. Good. Measurement unit. Without a measurement unit, this doesn't mean anything. Yes. Per. Now you can see, what is this? Well, if we divide 55 by 4, we would get what? Roughly 16. So roughly 16 or less, 15, you can say, well, you cannot round up. You don't have 5 cats. You cannot say that a 4.5 is 5 cats. Right, correct. So, but roughly 16 owls die per year. That's what it means. Okay, now we want to determine the equation. And we will, since we have the y-intercept, why not? Y equals mx plus b. So then y equals negative 55 over 4x plus 340. That will be our equation, only because we had the y-intercept. And now it says, final question, what does your model predict the owl population to be in 2012? For 2012. So for 2012, x will be very good. So of course 9 years. So we'll plug in y equals negative 55 over 4 multiplied by 9 plus 340. I would not, even if it's if I get the answer to be 200.9, I will not say that I have 201 hours. So I will not, because it's not money, or you know what I mean. So we're talking about population. So what do we get?
So population we round down.
If I say I have 3.5 cats, I actually have 3. I can't make one up and say I have 4. That's my recommendation. And plus 340. So 216.25 means nothing. So I'm going to say 216. Oops. This is not dollars. So this, if the model still holds, I don't know. I don't know when the model was determined. I don't know if in 2012 this was the correct result. But if the model still holds, mathematically this is the correct answer for 2012. Okay. Any questions? I would like us to go now to this handout that I don't have for you today. It was posted from the beginning of the semester. And I would like us to just choose one problem, and then we can do more next time, and I will ask you to work on a couple of them. And of course, I'm sorry. Please, please, okay. I have to say that the coordinator of this course, I think does a very good job in certain things. Like, for example, selecting these problems. All these problems come from the calculus book that we teach from. So, of course, we are not going to do the calculus part of the problem, but just the setting up and just working on these problems will help you. You'll have a head start, basically, in calculus. So, for example, this was a problem that we just did. This is what Mike asked earlier today, right? He invested blah, 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 how are the money, blah, blah, blah. It doesn't matter. It's the same thing. It's really the same type of problem. It's asking other things. What I recommend to do today is at least one of these. Let's start with number one. Let's read the problem and make a decision on what to do. A car A is traveling, this is from the calculus book, from related rates, section 3.9. Car A is traveling west at 40 miles per hour, and car B is traveling north at 55. So I already picture what's happening here. So I'm going to say problem one, supplement. So one is traveling west at 40 miles per hour. Because I pressed the document cam like the other room that I teach in instead of laptop. Sorry. Thank you, Mike. And the other car, so this is car A, and this is car B, going north 55 miles per hour. So this is what I picture immediately. I'll go back. Both are departing from the intersection of two roads at the same time. Very important. Write a function representing the distance between the two cars in terms of the time t in hours that has elapsed since the cars left the intersection. Okay. No. You'll see in a moment. So here's the situation. One goes north, the other one goes west. And we are asked to find the function about the distance between the two. So time elapses. They start at the same moment. So knowing that this one drives at 55 miles an hour, this distance, I'm going to call it y only because it's vertical, is definitely 55 miles per hour times time. At any point in time, let's say I leave Annapolis now and I drive with no stop at, let's say, a uniform, this is difficult, almost impossible, right? To have a constant or uniform speed. Let's assume this is an assumption for this problem. No one can drive at 55 miles an hour, right? I have to start from 0 to 55. I cannot just start at 55, right? So uniform motion is just a portion of we have to make that assumption, a portion of the trip. Okay, so I leave Annapolis now, and you ask me, I drive constantly, let's assume at 55 miles an hour, and you call me and you say where you are, and then I'll tell you where I am, and you'll measure, you'll know the distance, because I'm driving at 55 miles an hour, and in 2 hours you know where I am. Or in 3 hours you know where I am, right? The same thing for this, and I'm going to call this x, but this time is 40 times t. Again, we have to make the assumption of uniform motion. Uniform motion, which means constant speed. Not possible entirely, but let's say it's just that portion of the constant speed. So now I will call this d. And obviously, d squared will be x squared plus y squared because, can anyone explain? This is exactly, it's a 90-degree angle. It's a triangle, which is a right triangle. And the distance between the two cars is this. This is a distance, and it continues to increase, right? So I write d squared equals 40t everything squared plus 55t everything squared. And then I get 1600 t squared plus 55 squared is 572. What is it? 503. 3025 t squared. So then the distance equals the square root, and I add 1600 to it, and I get 4625 t squared. Yes, I can take the square root. I don't know if this is a perfect square. Is it? The 4625?
No.
No. So just leave it alone then. We can simplify it a little bit. So you have t the square root of 4625. And this is the formula for the distance between those two cars that is changing with respect to time. 1 hour after they start is 1 times the square root of 4625 in miles. 2 hours later is 2 times the square root of that, and so on and so forth. Any questions? Any questions? So I'll bring that supplement next time, and we will work on more problems, and then we'll select a couple for you to. The answers are here at the very end. I don't know what they came up with. Yes, because they simplified. So we should have done that too. We should have taken out the integers, the perfect square, not the integers. Okay. I would like us to continue unless you have questions for me. Any questions for me? Any questions? Any questions? Okay, so chapter 5. Although you can say, but what about 5.7? Yes, 5.7 was done because it was all about inverse functions, so that was done. So chapter 5 deals with functions. And you can say again, yes, the answer is yes, sorry. We will not look at linear functions anymore, we already did. So we will continue with quadratic functions. And again, you can say again. We already graphed them with transformations and everything. Now again, yes. Mainly, I would like us to graph the quadratic function step by step and then look at models. I don't want anything else there. Okay, so I'm just going to select, before we look at the problems in your book, I just want to select a problem like f of x equals negative x squared minus 6x minus 8. Is this quadratic? Yes. So let's say we want to graph. The correct steps are the following. We're not asked to graph using transformations. Okay, we're not going to complete the square. There is no need for that. But we're asked to graph using all steps, or presenting all steps. And the first step is the shape. We already know that the quadratic function looks like this. It can have one or the other. If it has a negative leading coefficient, it has a minimum or a maximum. Perfect. Very good. So this is a maximum, and the leading coefficient is negative. This is a minimum, and the leading coefficient is positive. So these are the only two possibilities for a quadratic function. If the leading coefficient is negative, the quadratic function has a maximum. And we know from x squared and negative x squared, right? And if it has a positive leading coefficient, positive minimum, negative maximum. This point, as well as this point, is called the vertex. Both of them. Plural vertices. So since I see that the leading coefficient is -1, which is a number less than 0, I know that the shape is this. And now the question is, why do I start with the shape? It's just to make sure that I don't make an error. That's how we start. We start with the shape. Number 2, the vertex. The vertex. You may remember or may not remember the coordinates of the vertex. Anyone remembers the coordinates of the vertex? Okay, let's stop here for a moment. Remember when we solved the equation ax squared plus bx plus c using the quadratic formula, what do we have? What do we write? Negative b plus or minus? Very good. B squared minus 4ac over 2a. The reason why I brought this up is because I want you to find a connection, because it's easier by connecting dots to remember. This, just this, is the x-coordinate of the vertex. So if you remember the quadratic formula, you should be able to remember the negative b over 2a. And that is the x of the vertex. Now, how do I determine the y-coordinate of the vertex? What do I have to do to find the y-coordinate of the vertex? If the x-coordinate turns out to be 5, how do I find the y-coordinate? Thank you. Of course, I plug it in. Very good. So let's find the x-coordinate of the vertex for this problem. Negative b over 2a, negative. How much is b? Perfect. How much is a? Very good. Times 2 is -2. I see 3 negatives. The answer must be excellent, and that's 3. So the x-coordinate of the vertex is -3. You already told me how to find the y-coordinate of the vertex. So f of -3 will be -3 squared minus 6 times -3 and minus 8. From your first test, I saw that you have some difficulties evaluating functions. So some of you wrote that this negative was somehow connected to the square and you changed it to positive. Please be careful. By the order of operations, we have to square this. We get 9. And 9 multiplied by -1 is -9. So please be careful with that. So -9, this is indeed positive 18 and minus 8. -17 plus 8 is positive 1. So we found the coordinates of the vertex. Now, I want another side explanation before we continue with step 3. I'm sure you're aware of this, but I just wanted to go over it again. This function has a maximum, right? For a quadratic function that has a maximum, there are only 3 possibilities. One possibility is when the quadratic function crosses the x-axis twice in 2 distinct points. The other possibility is when it doesn't even touch it at all. So there's no x-intercept. And here we say it still has 2 solutions, but they are the same. Still 2 solutions, but they are the same. So it's just tangent, it just touches, right, the x-axis. Now, I know that the vertex has x-coordinate -3 and 1 as the y-coordinate. Can I already picture the graph 1, 2, or 3? Of course. It is 1, it's not 2, and it's not 3. Here the vertex will be the x-intercept as well. So it has to have 0 as the y-coordinate, which it doesn't. Here it would have to stop below the x-axis, and this would have been what type of number? Negative. Negative, the y-coordinate, would have been a negative. The x-intercepts will be imaginary, correct. But this is the situation because the y-coordinate is positive. So the answer is above the x-axis. Because now the next step, step number 3, x-intercepts, if they exist. But I know that they exist because the graph is type 1. If I didn't know that, I would have not, it's possible that the function does not have x-intercepts and then I waste my time. But the vertex will always tell me whether to look for x-intercepts or not. And it tells me that I should look for the x-intercepts. How do I determine the x-intercepts? For any function. Very good. So I had negative x squared minus 6x minus 8 equals 0. Of course, we'll multiply by negative 1. We should always refuse to solve a quadratic equation with a negative leading coefficient. And the easiest thing to do is factor here. And if I factor, I get x plus 2 and x plus 4. And I get two options, negative 2 and negative 4. So then what are the ordered pairs? That will be the x-intercept. Excellent. Negative 2, 0, negative 4, 0. The y-intercept will always be there. There is no discussion if. So in step number 4, f of 0 for the y-intercept is negative 8, 0, 0, negative 8. So 0, negative 8. 5 and 6 and 7 are just words. The graph of a quadratic function. Yes, Bailey, any questions? Go ahead.
No, honey.
Did I do something?
No.
Okay. So axis of symmetry. So the parabola has a vertex. Oops, it has a maximum, sorry. It has a vertex at negative 3, 1. Can anyone give us the vertical line that passes through the vertex? X, vertical line, very good. X equals negative 3. So this does not mean that the function is odd or even. That's not what we're talking about here. We're just saying the graph is symmetric with respect to that line, x equals negative 3. Number 6. Since it has a maximum, max value is 1. Perfect. Last one, range. And you can say range, we haven't even graphed it yet. Yes, but we know we have the picture in our head already. What is the range of this function before we even graph it? Negative infinity to 1. Awesome. Well done.